My name is Whitney or Whit Garner, either one of those. I am a full-time instructor and curriculum developer here at Manhattan Prep. I've been with the company since 2010, and I'm excited about what we're going to talk about tonight because I've always been sort of a mathy person, but it was very hard for me to begin to adopt strategies for the quant section of the GRE that weren't really formal. Can other folks hear me okay? I assume so because you guys are telling me where you're from, but I can't. Yeah, so I was definitely a person who resisted doing math in what seemed like a way that you would cheat. I was a person that always wanted to do it the formal way. Let me see a show of hands. How many of you guys are, you can like raise your hand or what have you, but how many of you guys are people that when you see the quantitative section of the GRE think that you're supposed to be, doing a bunch of high school math or middle school algebra? Yeah, right. That's what I thought too. And for sure, right, there is going to be some of that on test day where we are going to need to know rules. You can check out some of our other free prep hours on things like exponents and weighted averages. You are going to need to know rules. You'll need to know geometry formulas and so on. But a lot of the time, if you understand a little of what's going on just sort of quantitatively in the background, there's a lot that we can do on the GRE without ever having to do the formal algebra that our like 8th grade teachers would be so proud of. And that's the plan this evening. So the plan tonight, we're going to be working through some problems from our GRE 5-pound practice book, right, available directly from us or from Amazon. And what we're going to do is we're going to talk about what in the world the most important part of a discrete quant question is. So when you have a discrete quant question, one of the flavors is multiple choice. Oh, nice, Damaris. I'm glad you have it. I love that book. But one of the primary parts of a DQ problem on the quant section is that it's got answer choices. Sometimes they'll be fill in the blank and sometimes it's choose all that apply, but a lot of the time you'll be given 5 answer choices. So here are 2 different problems. I want to get you guys' opinion. So let's take a moment to look at them both. But what is the most important part, do you think, of these 2 problems? What's the most important thing? And feel free to type in the chat. Simplifying, looking for digits. And so Jane said this beautifully. The answer choices, right? These are testing 2 different things. One of these is testing kind of computation of, simple addition, subtraction. One is a way more complicated set of fractions. But the thing that's important in one is the same thing that's important in the other. That we get in this habit of starting at the top left corner of a problem and working down, finding an answer, and then looking at the answer choices trying to match. And in fact, the answer choices themselves are some of the most important parts of these DQ questions. So tonight, the plan is to think about how to utilize the answer choices themselves directly, either to estimate, to weed out and eliminate, or maybe even solve. Right? So we're going to talk about how we use DQ questions in reverse. Right? How is it that we can start to incorporate the answer choices into our solving method? So for the problem on the left, notice how far apart those answer choices are. Notice how different they are. Jane mentioned eliminating answers that couldn't be true. Saltuna mentioned the last digit. But knowing those answer choices, I don't have to do the math. I don't have to sit down and write 572 and then subtract 318 from it. Instead, I can decide which of these answer choices is the closest because they're so far apart. So far apart. So I'm not going to take a number that's 572 and then subtract a number that's considerably, large over 300 and end up with still having 520 or even 460 left. It's just too big. In fact, I'm probably going to have something around 300, right? If I take a number that's a little, or even less than 300, if I take a number that's less than 600 and I subtract from it a number that's bigger than 300, I'm going to get a number that's less than 300. But I'm not going to get all the way down to 111. So without doing the math, I could get to answer choice B. I want you, without doing any of the math for this second one, way more complicated, I get it, but I want you to try and eliminate 2 or 3 answer choices just by looking at the problem and generally estimating the rough size of the pieces. I want you to type in the chat window, what would you eliminate? See them, keep them coming. So remember, I want you to tell me, what are you going to eliminate? Not what is the right answer, but I want everybody to type to me, what would you eliminate? What answer choices would you eliminate? All right, if you said A or B or C, why? Let me see. Art Thompson, do you have a working microphone by chance? Would you mind hopping on the mic and telling us? If not, that's okay. So let's take a look at these numbers. So help me out. We'll chat it in the chat window for me. Oh, that's okay. Yeah, so in this first fraction, which is bigger, the thing on the top or the thing on the bottom in my first fraction? The thing on the top. So if I have a fraction where the top, the numerator, is bigger than the denominator, what's true about that fraction? We don't even have to go quite that specific. It's going to be bigger than 1. Yeah, so our first fraction is bigger than 1. We're then going to subtract. What's our second fraction? Yeah, it's going to be at least bigger than the whole number. Exactly. What about our second fraction? Which is bigger, the top or the bottom? The bottom, which means the second fraction is less than 1. So if I take a number that's bigger than 1, we can debate what size. But if I take a number that's bigger than 1, and I subtract from it a number that's smaller than 1, is my answer going to be positive or negative? For sure, it's going to be positive. So I may not know exactly what the answer is, but if I'm pressed for time, I want to be able to look at my answer choices and at least know that it's going to be one of the positive 2 answers. All right. From there, if I have time to work through all the work, great. If not, then I want to flip a coin, right? Pick my favorite and keep going. But the idea here is that your answer choices can do a ton of the work for you because you can estimate, you can try and round or split them up. So let's try a couple more, right? So we'll try this one. I'm going to put a minute 45 on the clock. I want you to send me an answer. If you can send it to me privately, so you'd send it just to my name. Just to my name. All right. So what are some answer choices we can eliminate? Type it in the chat window. What can we get rid of? Because absolutely no way is it possible that the total number of sales, the total amount of sales for the first quarter. Yeah, right, for sure. If the whole pie, right, the entire pie is 1.2 million, so in other words, this guy, then a fraction of it, so Q1, cannot be bigger. That's too big. And it's certainly not going to be 18% of this big old number is not going to be $216. That's too little. And in fact, 2,000 isn't very much either. When we're talking about 18%, we're talking around about a fourth of it. Right? I mean, it's definitely less, but look at my only two answer choices that are left. Right? I want an answer. Like, look at my pie chart. It looks like I've sort of broken my pie into fours-ish. Right? So what would a fourth of it be? It's not going to be 21,000. Exactly. Like, this is way too small. So the only thing to be $250,000 is something that's pretty close to $250,000. And so our answer choices can provide a ton of relief from solving. So for this problem, I don't want your answer. Again, I'm going to give you 45 seconds this time. Actually, I'll give you 40 seconds. I want you to find me at least one answer choice that you can eliminate based just on understanding the story. And if you feel comfortable eliminating other ones, you're welcome to too. Nice, guys. How can we eliminate A and B? How do we know for sure? Definitely A, and then with a little bit more thought, definitely B. How can we get rid of those? Yeah. What was the price of the computer before the discount? After the discount, it was $612. Right? I started at something and shrank to $612. What was the price before? It can't be less than. And then for those of you that said, you know what, I could probably eliminate E as well. Why? Seems awfully big. $130 discount. Yeah, that seems definitely bigger than it. Like if I went from $750 and I dropped $130, $140, that's a lot more than 15%. That's a pretty steep discount. So we can probably get rid of E safely as well. Pick between C and D and keep going. Really? So the fact is that the GRE absolutely has answer choices like this. They are intentionally built into it. Why would, right? So let's think about a why. Let's think about our traps here. What do you guys think answer choice A probably is? 15% of this. Yeah, because somebody decided to like, I'm just going to follow a rule and I'm just going to try to do math and I'm going to stop thinking about it. Right? I'm going to turn off my intuition and I'm just going to try and solve. What do you think 520 is? It's if I drop 612 by 15. So it's the person said, I'm not going to use intuition. I'm just going to try and like crank out math. So the two answers, right, that you might have said are the most ridiculous. Like who would ever pick those? They're actually pretty common traps. People pick them because they take their intuition out of the game. And so that's the biggest thing tonight I want you to think about is that intuition, logic, and working with the answer choices is an integral part of this entire GRE process because we can get really, really, really far because the GRE doesn't expect us to be doing it. Right? Or they don't expect most people to be using these techniques. And so for that reason, we're going to exploit that. All right, we'll take it again. What answer choices? 40 seconds. Could you eliminate just generally understanding the relative sizes of things? Nice, guys. How did you decide to eliminate C and D? What is it that's problematic about C and D? Yeah, I want the ratio of dogs to birds, and there are definitely fewer dogs than birds by kind of a lot. Right? And so I definitely need a place where dogs are smaller than birds. And so I'm certainly getting rid of C and D, right? I need a ratio where it's a small thing relative to a big thing, 6 to 20. Now, if you know the rules for reducing, great. You could also eliminate E. That is a crazy ratio, right? The 1 to 26, there's not that many more birds. And so from here, you'd probably make the call between the two. They're pretty close to one another. And yeah, so Sarah, that's the thing, is if I know that I'm going to be working carefully, but with some of this like alternative-y kind of thinking with logic, I can slow down and take more time to make sure that I'm reading it. I don't think that it's true. No, not in this like whole version of the exam that exists now. There was a question in the background about has the quant section gotten harder? And no, I would say that as long as this current version of the GRE exists, where it's the section adaptive, it has not gotten harder. It cannot get harder, or else it won't be a standardized test. It is different from the old test that existed years and years and years and years and years ago, but definitely not the more recent one. All right, so we're gonna try it again. You have, 40 seconds. Again, we're just trying to understand the problem and see if we can eliminate anything. All right, guys. If I have a ratio of 0.4 to 5, I have a ratio of something really small to something pretty darn big. So I can eliminate what? Something really small to something really big. Definitely B. It's the wrong order. And definitely D. Yeah, D, those are too close. 4 to 5, those are really, really close. Now, I'd say 4 to 55 and 2 to 25 are pretty close, right? 4 to 45. So I would just kind of like hang on to those, make an estimation from there. I don't know that I'd say that A is way, way, way too big. It's definitely a little big. It's like, this number is 10 times over 10 times as big as this number, but this number is a little more than 10 times that number. So, but I mean, the correct answer on this one's actually C. So you'd be right if you had eliminated A. All right, let's try it again. Someone give you a little more time. It's like a minute and a half. See what you can eliminate. I'm getting lots of answers in. I love what I'm seeing. Like at a bare minimum, I want 1-inch square tiles covering the floor of a closet. And this thing is 5 feet by 4 feet. These are 1-inch square tiles, right? 5 by 4 would be 20. That's 20 feet, right? Like those would be huge tiles. So if I'm looking, right, I'm imagining this like little 1-inch square tiles and a room that's 5 feet by 4 feet. 20 and even 240 are tiny. Those are way too small. So even if that's it, even if that at a minimum, you were to get rid of those two, you're doing a phenomenal job. All right, let's try, we've got two, yeah, let's try this one. And then I'm gonna show you a really fun one that works with answer choices that usually kind of freaks people out. But give this one a try. One more. Minute long. Yeah, Tizetta, I'll go back over that one. Give this one a shot and I'll go back to that one. Nice. All right, so let's start to think about some of the things we could get rid of. Here's my guy's money, all of his income, and he spends half of it. And then like 20% of it on food. So half on rent, utility, insurance, 20% on food. What does that leave? We're just kind of thinking it through. We don't have to go far. What does it leave? I spent 50% and then another 20%. Yeah, this whole part down here is 30%. But I'm going to spend some of that. How much of that do I spend? Yeah, I spend a part of it. So I'm now going to spend a little part of this piece right here. So I'm going to, that's a little too big. I'll spend, you know, like a third of it, whatever. So I spend this part. This is what I have left. Well, this is definitely going to be less than having 30% left because that would be this whole block. And I definitely have something left, so I don't have 0% left. In fact, I probably have more than 15% left because this end is 30%. I didn't use up half of it. So I might even be good at getting rid of D. B and C are so close, we really couldn't make a call. We'd have to actually calculate it. And yeah, exactly. Like the way we would solve it would be to take 30% of 30% and then subtract it from our total. But if you're running short on time, that's a long way to go. B and C, like that's quick, right? You can get to B and C without a ton of effort. It can also help you get down to a narrow place and then make your estimation better. For the previous one, a similar visual could help. If you think about something that's 4 feet by 5 feet, right? So this is like 4-foot wall, and this is a 5-foot wall. How big is a 1-inch by 1-inch square tile going to be? Teeny, right? For each of those 4 feet, there's 12 inches. So across the top, there'd be 48 little bitty tiles across the top. Teeny, 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 right? There'd be like 48 of them. And along this end, all those 5 feet, each 5 feet would have 12 inches, each of those 5 feet. So that's like 60 of them, teeny, teeny, teeny. So we really got a number that's like 48 times 60. It's this huge number. There's no way that's going to be 20 or 240. No way. So I can absolutely eliminate those two. All right, so here comes my other favorite. Let's see. That's a good question. What did you run? What did you throw into? Yeah, it's E. But remember, point is, I'm not trying to do the math. We're just trying to estimate. Okay, so here comes another one. This one, I'm going to give you the full 2 minutes. I want you to tell me what you think the actual answer is. And I want to see, you know, how, we'll chat about how you got there. All right, the first thing I love is so many people are like, oh my gosh, I hate this stuff. This stuff is so confusing. All right, so here's what I want you to do. I don't want you to think about this with math, not with actual math. Let's think about this logically. First, we've got Janice. Right? We've got our friend Janice, and Janice takes 13 hours. If I show up to help Janice assemble tanks, is it going to take more than 13 hours or less than 13 hours with my help? It's going to take less, right? And so if Janice gets Sabrina's help, it's going to take less. And so it's definitely not going to be a number over 13 hours. But what if Sabrina shows up by herself? She takes 8 hours, right? So ignore Janice for a second. Let's pretend that Sabrina is here working. Takes her normally 8 hours. If someone comes to help her, is it going to take more than 8 hours or less than 8 hours? It better take less, right? If she's got help, right? If she's sitting here with help. So Sabrina can do it in 8 hours by herself. So if somebody comes to help her, yeah, then it's going to be faster than 8 hours. So here's what we know. We know that it's got to be something that's faster than 8 hours. And so we're down to 3 answer choices, and that might be enough. But now let's go back to our friend. Well, let's go to Sabrina for a second. Let's stay there. So Sabrina's our fast worker, right? She's our Speedy Gonzalez. Question is, though, is what if instead of bringing Janice along, who's considerably slower, what if Sabrina instead got to clone herself? And so there were two of her. So what if Sabrina basically got a body double? How long would it take for Sabrina and her twin to finish the job? Yeah, that I can do, right? 4 hours. If you and I work at the same rate, it would take us 4 hours. Okay. But then what if that was true for Janice? Let's look at Janice's story. If there was a, if Janice had a body double, how long would it take Janice? So if I had 2 slow workers, nice, it'd have 6.5 hours. Because she's doubled, right? And so the answer, we don't have 2 fast workers. We don't have 2 slow workers. We have 1 of each. And so, oh my gosh, the answer is infecting. Well, and we don't know the exact one, right? Like, even if they say approximately, I don't care approximate, right? It's somewhere between 4 and 6.5, swindled. So when you're dealing, these like combined work problems stress people out like crazy. And they're some of the best ones, the very best ones to estimate on, even when they don't say approximately. Yeah, but you don't have to anymore. How about that? So just to prove it, right? We're just going to be able to like kind of get down, but at least get us close. Give it a go. All right, so let's start with the first part. There we go. Let me show my chair again. There we go. All right, so let's start with our first bit of information. What do we know? What has to be true about, like let's say if Wendy is doing it by herself, right? Wendy builds a birdhouse in 15 hours. If she has a clone, right? If she gets doubled, then what? Yeah, so her body double. She finished in 7.5 hours. Okay, Miguel is faster. Miguel normally would take 10 hours. If Miguel got a body double, yeah, they'd be done in 5. Him and his twin, they'd be done in 5. So the correct answer has to be between 5 and 7. Or 7.5, excuse me. 5 and 7.5. And so this range, if we were to look at it, like 5, it's not going to be right in the middle, but it's going to be more in the middle than way off to one end. And so like 6 point something would be in the middle, 6.25 would be in the middle. And so it's going to be a lot closer, most likely to 6. And so that would be a really safe bet. And we'd be right. And the correct answer would be B. Without a bunch of crazy math, yay. Better? A little bit? Yeah, agreed. Agreed. Okay. So, what is the most important part of a discrete quant question? What do you guys think it is? Patton, that is true. That's the algebra. That's the algebra. Yeah. It is don't panic. That's probably the most important. But what is the most important part of a discrete quant question, a multiple choice question? Maybe those are the pieces, but it's the answer choices. Right? It's the answer choices. We have to know what we're solving for. We have to know where we're headed. Right? We have to be able to decide, are the answer choices something even I can utilize? If they're really spread out, or if like we saw those ratios where one's bigger than the other. So I'll often argue that the single most important part of all discrete quant questions, the one thing that they all have in common is that when they have answer choices, those answer choices are extremely important. Now, those answer choices are so important, in fact, that they can save us from a lot of algebra. So I want you guys to try this problem however you want to do it. I'm going to give you 1:40, and then we'll talk. All right, show of hands. How many of you guys made some equations? Okay, hands down. How many of you guys eliminated any answer choices because they were ridiculous? Perfect. Okay, so what are a couple of answer choices that can absolutely be eliminated because they're ridiculous? Yes. Right, so there's no way, right? There's no way that if she buys a total of 12 pieces of fruit and she buys more apples and pears, that she bought 12 pears or 24 pears. That's crazy. Those are huge. That's just silliness. Okay. We can also get rid of A because that's way too small. And in fact, this is a perfect question to start to look at. What's another way we could use our answer choices? We could use some of this elimination estimating. We can also work directly from them. Because if this is the number of pears and she bought 2 more apples than pears, Well, that's not enough to make 12. And if she bought 2 more apples than pears, boom, there it is. 7 and 5 would be 12. 7 plus 2 would be too big. C is the trap answer when we solve for it backwards. You'd say apples instead of pears. So one of the things to think about is sometimes these word problems, particularly ones that involve more than one variable, can be a lot easier if you just kind of work through use the answer choices. So that's what we're going to try. We're going to spend the last little bit of our session today looking at how we could use the answer choices for some of the least pleasant of the word problems. Right? So I want you to resist the urge to write equations. Resist the urge, because we're going to make it a little harder. Well, that's where Saltune, a great question, right? How do I know when to work from the answer choices? What we're looking at, there are a lot of different reasons why. What we're looking for here is, as you read, when can you start to think like, well, wait, are the answer choices actually like a part of the problem that I could plug in? Yeah. So if we look back at this piece, notice what the answer choices were. They were a nice simple value, pears. And if I knew pears, well, I could get apples, right? And if I knew apples, then I could check with whether that's actually how much she bought. I'm going to come back around to that exact same question. You're like, well, how do we know? After we've done a couple more, because I want you to see it, right? I want you to start to see all of the scenarios, because everything I'm about to give you are questions where you could use the answer choices through a process of eliminating some and then using them to plug into the problem to get to an answer in some ways a lot easier than trying to set up the equation. Another great question, which is what percent of the quant questions don't have answer choices? So fill in the blank or very few and far between. There are very few in terms of the questions on the section, maybe 2. Far more likely to have multiple choice answers. All right, here we go. Let's try it. Minute 25. All right. So what could we do to use this one? How could I use the answer choices for this one? What do the answer choices represent here? What are they? Yeah, they're granddaughters, right? These are the daughters. These are the granddaughters. I'll just clear it up. I'll write it in text. So these are the daughters. And just think about the story. She has 3 times as many granddaughters as grandsons. So if she had like 3 granddaughters, she would have 3 grandsons, right? We can read this without thinking of algebra. I could tell you like, oh my gosh, she's got 3 times as many dogs as cats. And I know what we mean. That would mean 1 here. But hold on, what answer choices then would have to go if granddaughters were 3 times as more frequent than grandsons? Well, it's definitely not going to be A, because 3 granddaughters and 1 grandson is not enough. But could I have 4 granddaughters? No, because how many grandsons would I have? That doesn't work. 4 isn't 3 times as many as something else. And by the way, neither is 8. So if I had 6 granddaughters, I would have 2 grandsons, because that's 3 times as many. That's still too small. If I had 9 granddaughters, I'd have 3 grandsons. There's my 12. Yes, the correct answer is E. Right? So again, if you're like, yeah, but I feel really good with algebra. But I mean, like, writing equations is so easy. Okay. Okay. I hear you. What about this problem? I'm going to give you enough time to try it 2 different ways. Okay. I'm going to give you guys, let's call it 3.5 minutes. First, I want you to solve it with algebra. So try and write. I want you to try, no matter what. I want you to try and write equations. Second, I then want you to use the answer choices. And then we'll talk about like the difference. So here's your 3.5 minutes. So I'm seeing so much that's like, I took a practice test like this and a problem came up just like this and it was terrible. I didn't know how to do it. And like, I don't even know how I would set this up with algebra. It's like a mess. I'm not getting a ton of answers in. How many of you guys tried this with algebra? And so hands up if you tried it with algebra and liked it. How many of you guys tried it with algebra and got stuck? All right, if we want to do this with algebra, here's the reason why age problems can get really funky. Let's say we establish some variables where n will be Norman right now. So we'll kind of get organized. So right now, Norman is n and Michael is m. But in 6 years, Norman would be n plus 6 and Michael would be m plus 6. So my first equation would be to say that Norman is currently 12 years older than Michael. But my next equation is like the 6 years from now thing. Like in 6 years. So if I took Norman and I made him 6 years older, he's going to be twice as old as Michael will be in 6 years. So I have to remember all these little pieces. And then I have to do a system of equations. I have to go plug one into the other and solve it. But if these are Michael, and this, so let's come up with Norman. Norman is 12 years older. So Norman's either like 15 or 18 or 24 or 30 or 36. Those are Norman's possible ages. In 6 years, right, so if I take them both up in 6 years, so let's see where we are. I might just pick one somewhere in the middle kind of and see. In 6 years, is he going to be twice as old as Michael is? This would be 12 and 20. Wow, that one worked. You could have tested them all, right? So 9 and 21. No, he's not twice as old. Right. But 12 and 24. There's our answer. If you had tested a different one, right? 18 and 30. He's not quite, right? In this case, he was over twice. Now he's under twice. Yeah, you were exactly right. I want to try the same thing. Same thing, right? Let's try one more. I'll give you a minute and 30, minute 40. Nice. Nice. So I had a question about the last one. Like I did it wrong because I subtracted. What you would need to be thinking about is like the time period, because it depends on, right? Like if he's currently, right, this age, in 6 years, that would be adding. So we'd add 6 years to it from now. Okay, but if we come back to our crunchy custard problem, we have 2 types of donuts. Look at how nice and pretty and easy those answer choices are. 1, 2, 3, 4, 5. He ate 5 total donuts. 5 total donuts. How many of them were glazed? So these would be glazed, which would mean cream filled would be the other ones. So if he ate only glazed, no cream filled, he would have only eaten an even 2,000. That's too many. 5 donuts at 200 calories a piece, that's too much. So now we can look at, like, find that sort of balance. Like at this 3 and 2, if you eat 3 glazed, that's 600 plus 2 cream filled, which would have been 720. And that's not enough. It's not enough. It's only 1320. So if we go up to 4, this would be 800. I'm going the wrong way. Just kidding. Go the other way. Not enough. If we do 2 of these, this is 400. Plus 3 of the 360. You can grab your calculator. Right? You'll have your little 3 times 360. Is 1080. Where did it go? 1080. So now I'm up to 1480, so still not enough. This would have been 1320, so the answer has to have been A. And if you'd started with A and worked on, you'd have hit it from the very beginning. So for a lot of these, I just work straight through them. And so yes, you could of course do algebra on these, by all means. At the same time, it can be nice, especially as the word problems get trickier and trickier. So one of the great questions was like, how the heck do I know? When you're dealing with word problems and the question is asking you, so we'll look at a couple of these examples. Notice that the question is asking you for a simple value. How many of the donuts were glazed? How old is this person right now? Single age. How many granddaughters did someone have? How many pairs did they buy? Simple, clean numbers. Consider plugging in the answer choices. Yeah. Thanks so much, you guys. Just to let you know, all of our upcoming courses, you can try any of our sessions in person or online for free, the first session. We also have our Interact products online available as well, and our 5-pound book available both on Amazon and from us directly. So I want to wish you the very best of luck as you start to study for the GRE. We're here if we can help you at all. Let us know. And good luck.